So this video is integrated to Circle Mania and the backside, which is practice with circles. So on this first problem here, we know that this arc is measures 40 degrees, which means that this one here, I'm doing a different color. This one here is going to be the rest of 180 because together they form a semicircle because this is a diameter. So this is going to be 140 degrees. Now on the other side, I know that this is 100 degrees. So I know that this piece right here is going to be the rest of its 180 degrees, okay, which is going to be 80 degrees. Now, the angle we're looking for is not an inscribed angle and it's not a central angle, but this angle here can be found if we think about this chord and this chord, and we take the 140 degrees and add it with the 80 degrees, which are the two arcs measures that it forms, and divide by 2. So we are going to take 140 plus 80, which is 220 divided by 2, and we get 110 degrees. So this is going to be 110 degrees. X equals 110 degrees. On number 2, in this situation, we're trying to find the area of the sector. We know that the radius is 6, and so we know that the area of a circle is pi r squared. So the whole entire circle would have an area of 36 pi, but I don't have the whole circle. I only have this portion, which is 120 degrees out of 360 degrees. And I'm going to times that with 36 pi. And I can do a little simplifying here. Those are going to cancel out. I end up with 36 and 36. So my answer, the area of the sector, okay, is going to be 12 pi. On number 3, we know that PT is tangent. So right here at this point, that is a point of tangency. So that also lets me know that if I draw a line from my center to that point of tangency, that is going to form a right angle. Okay, so that's going to be a right angle. I also know that MP, this portion right here, is 4. And we also know that the area of the circle, so the area of the circle, which is always pi r squared, is equal to 25 pi, which means my r has to be 5. So now I know that this is 5. And if that is 5, I also know, because this is also a radius, that this is 5. So I have a right triangle with a 9 here and a 5 here. And I'm trying to find this. So I'm going to use Pythagorean theorem. And I am going to do 5 squared plus x squared equals 9 squared. So basically x squared is going to be 81 minus 25. So I'm going to take 81 minus 25. So 81 minus 25. And I'm going to get 56. So then my answer is going to be the square root of 56, or about a 7.48. So my length of PT is going to equal the square root of 56, which I could simplify because that's 8 times 7. So that would be a 2 root 14, or I can give it as 7.48. On number 3, in this situation, we know that A is a point of tangency, B is a point of tangency. So that means that I have a right angle there, and let me make this a little bigger. I have a right angle here. I also know that OA, which is going to be the radius, is 8, which means that going to here is also 8. I know that angle AXB, or I should say arc, that should have arc on it. Okay, arc AXB is 240 degrees, which means that this opposite side here is going to be the rest of 360, which is going to be 120 degrees, which means that central angle here is also 120 degrees. Now I am going to draw a line from my center O to C, splitting this in half. And so that was 120 degrees, but now this angle here that has been split is going to be a 60 and a 60. So when they want us to find BC, okay, this is BC right there. I have a 30, 60, 90 right triangle. Okay, so I have a 30, 60, 90 right triangle. And if this is O and this is C and this is B, I know that this is 8. I know that this is 60, and I want to find that. So this is a 30, 60, 90 right triangle. So if that is 8, then this is going to be 8 root 3, and that is our answer. On number 4, we know that AE is 3 in the color code. We know that AD, this whole AD is 12. So if that's 12, this has to be 9. We also know that BE is 14. So if that is 14, and we want to find EC, which I'll do in red, okay, I'll call that X. I know that if I take my 3 and 9 and multiply those segments together, it's going to equal the same as 14 times the other segment X. So I basically have 27 is equal to 14X. I divide both sides by 14, and that is our answer. That's the length of EC. On number 5, in this one, I know that QP is tangent at point Q. So this is going to be tangent, which means when I draw this, this is going to make a right angle with the line. We also know that ON is 8. Okay, so this right here is going to be 8, which also means this right here is going to be 8 because they're both radii. We know that NP is 2, so let me scooch this in. So this is going to be 2. And they want us to find this piece right here that I'm going to call X. So in this situation, I have a right triangle. We'll kind of draw it the same way this one is. Okay, so I have a right triangle. This is going to be O. This is O. This is Q. This is P. We know that this is 10. This is our right angle. And this is 8. So I can do Pythagorean, but this is actually going to be a 3, 4, 5 right triangle. So 4 times 2 is 8, 5 times 2 is 10, so 3 times 2 is 6. So that is going to be 6. But you can also do Pythagorean theorem. Okay, on number 6, we want to find the area of circle Z, and then we also want to calculate the arc length of XV. Okay, so in this situation, I know that this angle is 40 degrees, which means that this right here is going to be 20 degrees because it's an inscribed angle. Okay, I'm just going to zoom in so I can write my 20. Okay, so that's going to be 20 degrees. I also know that this length here is 9. And because this right here is a diameter, that means that this inscribed angle is 90 degrees. So I have a right triangle here. And I am going to need to find my hypotenuse basically. So if I have my triangle, and I'm going to label this V, this X, this Y. Okay, this is 9, this is 20 degrees. And I want to find this that I'm going to call D for diameter. Okay, so I'm going to be using some trigonometry for this. So I am going to do, I've got, let's see, adjacent and hypotenuse, adjacent hypotenuse. So I'm going to go cosine of 20 degrees equals adjacent over hypotenuse. So I get D times cosine of 20 degrees is equal to 9. So D is going to equal 9 divided by cosine of 20 degrees. And I'm going to put that into my calculator. Into my calculators in degrees. So 9 over cosine of 20, I end up with 9.57. So this is 9 point, let's say 5.8. Now my radius is going to be half of that. So I'm going to divide that by 2. And so my radius, let me do this in a different color. My radius was half of that, which was 4 point, let's say 7.9. So now when I am trying to find my area equals pi r squared. And so I'm going to take my r, which was 4 point, let's say 7.9, square it, and times it by pi. So I'm just going to square this. So I get A equals 22, let's say 0.93 pi, which is approximately 72.04 square units. Now, the next thing they want us to do is calculate the length, the arc length, XV. So in this picture, that arc length is going to be, do it in orange, I'm gonna zoom in, right here. This is what I'm trying to find, that arc length, not the arc measure, but the arc length. So in this situation, I need to figure out what portion of this I have. Since this is 40 degrees, this is going to be the rest of the 180, which is going to be 140 degrees. That's my arc measure, not my arc length. But this central angle I just drew in, which is also going to be 140, is going to be the part of the circumference I have. Now, circumference is equal to pi times diameter, or 2 pi r. So I am going to take pi times my diameter, which was 9.58, and put that into my calculator. Okay, so I'm going to go 9.58 times pi. And I end up with 30 point, let's say 30.10. I do not have this whole entire thing. I have a portion of it. I have 140 out of 360 degrees times 30.10. I'm going to put that into my calculator. So I'm going to have 140 over 360 times 30.10, and I get 11.71. 11.71 units. Centimeters in that case. This one is centimeter squared. Okay, on number 7. In this situation, if I know that that is 35 degrees and this is a point of tangency, that means that this is 90 degrees. So I'm going to go 180 minus 35 minus 90, and that is going to give me X. So I'm going to take 180 minus 35 minus 90, and I end up with 55. So X is equal to 55 degrees. On letter B, we have this central angle, that's 120, that forms this arc. And that arc is also formed by this inscribed angle. So X is going to be half of that. So it's going to be 60 degrees. On C, we have this inscribed angle that's 46 degrees that forms this arc. So I'm going to take 46 and times it by 2. And 46 times 2 is 92 degrees. So X is going to equal 92 degrees. On D, I'm trying to find that X. What I'm going to look at is this right here is 42 degrees, which means this arc here is going to be double that, which is 84 degrees. Now, if that is 84 degrees and it is formed by this central angle, then this right here is going to be 84 degrees. So I'm trying to get this a little smaller. 84 degrees. And if that is 84 degrees, because these are vertical angles, this angle here and this angle here are going to be the same. So my X is going to be 84 degrees. Okay, so practice with circles. So in this situation, I am trying to find X, Y, and Z. I have this arc that is formed by this central angle. So this central angle is going to be the same. It's going to be 100 degrees. I have this inscribed angle that also forms that same arc. So it's going to be half. It's going to be 50 degrees. And I have this other inscribed angle that also forms that. So it is also going to be 50 degrees. So I've got 50, 50, and 100 degrees. On 2, we know that these are tangent. So this and this are tangent, which means that this is going to form a right angle, this is going to form a right angle. We know that BOX is 120 degrees. So I know that this right here is 120 degrees. Okay, this right here is my 120 degrees. And when I cut this in half, that means that these are going to be 60 each. Okay, those are 60. And we want to find the measure of angle BTX. So if I'm trying to find the measure of BTX, a couple ways I can think about it. If right now I know that I have two right triangles, okay, this right triangle here, where I have a 60 degree, that other one here is going to have to be 30 degrees, which means this is also 30. So BTX is going to be 60 degrees because it's going to be a 30 and a 30. On number 3, we know that DV is 9, so this is 9. SV is 12, so we know that this piece here is 12. We know that AV is 4, and we want to find IV. So I'm going to take the line segments and multiply them together. So I know 9 times, we're going to call that X, is equal to 4 times 12. 4 times 12. And so I basically get 9x is equal to 48. So I get x is equal to 48 divided by 9, which I could divide by 3 and get 16/3. On number 4, so in this situation, I know W, let me do it in a different color. I know WPX is 28 degrees. I know that ZPY is 38 degrees. And we know that WZ and XV are diameters. So if we know that those are diameters, then what I know is that we have a linear pair with this. So if that is a 28, I'm going to be taking 180 minus 28, and I'm going to get 152 right there. So this is going to be 152 degrees. I know that if this is 28, this is going to be 28 because those are going to be vertical angles. I also know that if I am looking at this, that those are going to be 180. So I take 180 minus 28 minus 38, and I get that this is 114. Okay, so now let's take a look at the questions they're asking. So they want our arc measure for YZ. So YZ right here, it is going to be 38. They want to know what's the arc measure of WX. So the arc measure of WX is also has a center angle, so it's going to be 28. They want us to find angle VPZ, angle VPZ, so V, oops, I'm in the eraser. So VP Z is going to be 28 degrees. They want us to find angle arc measure of VWX. So VWX, VWX is this. That's going to be 180 degrees. They want us to find XPY. So XPY, XPY, that's going to be 114 degrees. They want us to find XY. So the arc XY, that's going to be 114 degrees. They want us to find the measure of XWY. So XWY, XWY goes all the way to here. So that's basically going to be equal to 360 degrees minus the 114, which is going to be 246. So that's going to be 246 degrees. And the last one here, we're looking at WZX. So WZX would be going all the way to here. And so that is going to be 360 minus 28, which is 332 degrees. So this next section, my X, if this is 136 and this inscribed angle forms the same one, it's going to be 136 divided by 2, which is 68 degrees. On the next one, I know that this is going to be the rest of 360. So I basically have 250 that I'm going to be subtracting from 360. So I'm going to get 110 degrees. And so if that's 110 degrees and I take half of 110 degrees, I'm going to get 55 degrees. So X is going to be 55 degrees. In this situation, we have this inscribed angle that forms this arc I'm drawing in blue, but I have this other inscribed angle that forms the same arc. So X is going to be 18 degrees. Okay, in this one, EWA is that inscribed angle that we know this arc right here is 62 degrees, which means that's going to be half of that, which is going to be 31 degrees. We want to find WET. So WET, and we know that this arc here has a measure of 86 degrees. So WET is going to be half of that, which is going to be 43 degrees. WES, oops. So WES is right here. Well, I know that, so that's what I want, but what I know is the following. I know that if I am looking at this angle here, this one right here, that is going to be 43 degrees because it's going to be half. So this is 43 degrees. And if that's 43 degrees, that angle plus the one I want are supplementary, they're a linear pair. So I'm going to be doing 180 minus 43, and I'm going to get 137. So I know that this one here is 137 degrees. Then they want WST. So WST. And I can find that by taking the 86 degrees minus the 62 degrees, the two arcs that it intercepts, divided by 2. So I'm going to take 86 minus 62 divided by 2, and I get 12. And that's the answer here. This is 12 degrees. On number 9, I'm trying to write this as equation of a circle, identify the center and the radius. So we're going to have x squared plus 6x plus something plus x squared, sorry, not x squared, y squared minus 4y plus something equals -9. And then I am going to be adding in to the first one, half of 6 is 3, 3 squared is 9. So I'm going to add 9. Half of -4 is -2, and -2 squared is 4. So I'm going to be adding 4. So I am going to end up with x plus 3 squared plus the quantity y minus 2 squared is equal to 4. So my center is -3, comma 2, because -3, comma 2. And then my radius is the square root of that 4, which is 2. Equation of this circle. So looking at this, it looks like my center is right here, and that's at -1, -1, comma 1, 2, 3, 4, 5. So that's at -1, comma -5. And my radius is 4. So this is going to be x plus 1 squared plus y plus 5 squared equals 4 squared, which is 16. And that's the end of this video.